All right, chemistry kids, this is just a continuation of the nuclear lesson we were just talking about. So this is 2-5. I just want to go to the whiteboard and show you how to set up some of these nuclear equations. And that'll be it, and then we'll talk about half-life another time. All right, so let me head over to the whiteboard. Okay, so like we said before, if you see the word decay, eject, emit, that means whatever particle we were talking about, it could be alpha, it could be beta, it could be a positron, is being ejected from the nucleus. So if we, if I just said thorium-234 undergoes alpha decay. So let's say thorium-234, atomic number 90. If I say that undergoes alpha decay, what we're going to be doing is I would write thorium-234 and then yields an alpha particle. Okay, so I got to memorize what an alpha particle is, mass number, atomic number. And then the question is, what does the thorium turn into? So if I want to, I'll put plus and I'll put x, that's going to be my unknown. And really I'm trying to solve for that number and I'm trying to solve for that number, okay? And so this is an equal sign, okay? So the numbers on top, on this side, have to add up to the numbers on top on that side, and the same thing for the numbers on the bottom. So it's pretty easy math here, right? This is an equal sign. So 234 equals 4 plus our unknown. So that means this has to be 230, okay? And then 90 equals 2 plus that unknown, okay? So this would be 88, okay? And then to figure out what that symbol should be, okay, for X, you go to your periodic table and you find number 88, atomic number 88, and that is radium, and that would be Ra. So if I asked you what is produced when thorium-234 undergoes alpha decay, this is how you figure it out. The answer would be it turns into radium-230, okay? But if I said thorium-234 undergoes neutron bombardment, that means the neutron isn't leaving the thorium nucleus, that means it's being added to. So the way that equation would look is I would say, okay, well, my thorium-234 is bombarded with a neutron, then we would say plus a neutron. Okay, so neutron has a mass of 1, charge of 0. And now I'll write my yield sign, and now I'm trying to figure out what this should be. Okay, so I got to figure out that unknown and that unknown. And again, my yield sign is an equal sign. So it would be 234 plus 1 equals that. So this would end up being 235. And this would be 90 plus 0 equals that. So it's 90. And then since it has the same atomic number, it's thorium. So that would be thorium-234 becomes thorium-235 after neutron capture or neutron bombardment. Okay? So let's keep going. What if I said something underwent alpha decay and beta decay? Okay, let's say, again, I'm just going to stick with uranium, but it could be anything. I could say polonium-208 undergoes beta decay and alpha decay. So let's do that. Okay, so polonium-208. So I'll say polonium-208, and polonium's atomic number is 84. And let's say it went alpha decay and beta decay. So decay would mean that's leaving the nucleus, so it's going to be on this side of the yield sign, an alpha particle. But then it also lost the beta particle, so I would write that. And then again, we're trying to figure out what that is. Now, there's one way to do it, is just one full equation. You can include everything in just one equation. Or you could have shown polonium 208 undergoing alpha decay and figure out what that turns into, and then take that and undergo beta decay and see what that turns into, it'll come out to be the same answer. Again, it's not difficult math. This is an equal sign, so it would be 208 equals 4 plus 0 plus x. So if you want to set it up like an equation, you could say 208 equals 4 plus 0 plus our unknown plus x, okay? So to solve that, we just subtract 4, okay? Subtract 4, subtract 0, so 204, okay? And this, where you have the -1 here, that's where kids get thrown off a little bit, but we could set it up just the same way. We would say 84 equals 2 plus a -1, okay? Plus our unknown there, we'll call it y, okay? So it's really going to be 84 minus 2, but then plus 1. So 84 minus 2 is 82, but then the -1 is going to end up being plus 1. So this is going to end up being 83, okay? Then you go to your periodic table, and you go, what's number 83? It's bismuth. Find the chemical symbol, and that's what you get, okay? Then you could have something where you could have both things. We could say uranium-235 undergoes neutron bombardment, which leads to positron emission, okay? And again, I'm just making this up, but if I said uranium-235 underwent neutron bombardment, that would mean plus a neutron, and then that triggered positron emission. So now I would write my positron particle. Okay, remember, positron is the same as a beta particle, just with a positive one here instead of a negative one. Okay, and then we would say plus, our unknown. So we're trying to figure that out. So this would be 235 plus 1, okay, equals 0 plus our unknown. So this ends up being 236. 236, okay? And this would be 92 plus 0. Okay, so 92, and then minus 1 for that one. So this would end up being 91. Go to our periodic table. 91 is protactinium, Pa, and that's what we got. Okay? So again, your teacher will have more practice with nuclear equations for you, but that's essentially the gist of it. What you want to remember is what an alpha particle is, what a beta particle is, what gamma radiation is. Kind of just remember how to write them in terms of our isotope notation. This is how I write an alpha particle, this is how I write a neutron, this is how I write a beta particle, this is how I write a positron. Just things like that. And remember, you would always get a periodic table while you're doing all this stuff. But just understand, how to find these symbols. It just matches up with the atomic number. Okay? So we'll review half-life next time, but that is most of 2-5, and hopefully you have a better understanding of it now. Okay?